Welcome. In this tutorial, we'll build a JavaScript program that uses recursion to search for a number in a sorted array using the binary search algorithm. This divide and conquer approach makes searching efficient and elegant. It is a great example of recursion in algorithm design. Let's get started. We're given a sorted array and a target value. The binary search algorithm splits the array in half repeatedly to find the target efficiently. If the target is found, we return its index. Otherwise, we simply return -1. Let's look at the JavaScript code that makes it happen. We define a recursive function binary search that takes an array, a target, and an optional start and end indices. If start exceeds end, the target isn't in the array. Otherwise, we find the midpoint and compare it with the target. Depending on the result, we search either the left or the right half. The binary search algorithm divides the array into halves each step. If the target matches the midpoint, we return the index. If the target is less, we search the left half. If it is greater, we search the right half. This continues until we find the target or exhaust the array. Let's walk through the example with the target being 6. We start with the full array, midpoint 11, and move left. Then, midpoint 5, 6 is greater, so we move right. Finally, we find 6 at index 4. This demonstrates how binary search halves the search range efficiently. Binary search is essential in computer science for searching in sorted data efficiently. It is widely used in database systems, file systems, and more. It is also a classic interview question that tests recursion and algorithm skills. Let's wrap it up with a summary. We've built a recursive function to perform binary search and on a sorted array. This divide and conquer approach makes searching efficient and fast. Test it with different targets to see how it works. Thank you for watching. If you enjoyed this video, please make sure to like, share and subscribe for more JavaScript tutorials. I'll see you in the next one.